Hello students, today we will discuss about nanoscience and nanotechnology. So what do you mean by nanoscience and nanotechnology? So nanotechnology is defined as ability to engineer materials precisely at the range of nanometer scale, or we can put it in this way, that is designing and fabricating materials, devices or systems with control at nanometer dimension. So the essence of nanoscience and nanotechnology is the size of the material or device and how do you control that device or material. So nanoscience in turn is an observation and study of phenomena that is involved at the nanometer scale. While technology is to engineer, nanoscience is to observe and study. So we will be checking what are the ways of manipulating matter at the nanometer scale. So it was Lindsay who put forward the idea that the nanoscience is not confined to any particular discipline of science. Nanoscience is actually not physics, chemistry, engineering or biology. It is all of them. So the first idea of nanotechnology or nanoscience was given by Richard Feynman in his lecture, There is Plenty of Room at the Bottom, which was given to the American Physical Society in 1959. Okay, it's almost like 60 years from now. Richard Feynman assumed that as soon as I mention this, people tell me about miniaturization and how far it has progressed today. They will tell me about electric motors that are the size of nail on your small finger. Okay, the size of the motors is of the size of a small finger. And there is a device on the market, they tell me, by which you can write the Lord's Prayer on the head of a pin. Okay, in such a very minute way you can write down things, or you can come down to the level of nanometer scale. But that's nothing. That's the most primitive halting step in the direction I intend to discuss. It is a staggeringly small world that is below. In the year 2000, when they look back at this age, they will wonder why it was not until the year 1960 that anybody began seriously to move in this direction. I caught Richard Feynman in his lecture, There is Plenty of Room at the Bottom. So what does this lecture say about? Yeah, he is mentioning about how the people are manipulating or working at the nanoscale, how the size of the motors have reduced, and how control can be made at the level of the head of a pin. Okay, and he is also posting on the public that, or wondering why it was not until 1960 no one else think about that's very nano level beyond. So in his famous lecture, There is Plenty of Room at the Bottom, in 1959, he considered the possibility of controlling individual atoms as a more powerful new form of chemistry, and he also envisioned of building circuits which are on the scale of nanometers and that can be used as elements in powerful computers. And imagine, it is the time when were the computers were like very massive, occupying the entire room. So then he was anticipating a technological innovation which will make or which will allow us to build circuits on the scale of nanometers. So, the term nanotechnology was actually coined by Norio Tangoshi in 1974 in his paper on the basic concept of nanotechnology, which was published as a proceedings of International Conference in Production Engineering, Tokyo, where he presented his paper on nanotechnology. And it describes semiconductor processes such as thin film deposition, iron beam milling, which exhibit control on the order of nanometer and all. So, according to him, nanotechnology is mainly consisting of processing, separation, consolidation, and deformation of material by one atom or one molecule. So, the actual emergence of the concept of nanotechnology happened with Eric Drexler. So, according to him, he envisioned of building up self-replicating nanobots or self-replicating robots at the molecular scale. So, what is the specialty of self-replicating robots? He assumed that these robots can align themselves in very different way to build up structures. Like maybe a building can be built up all on a sudden, or a bridge can be built up. Hope you have watched the Big Hero 6 movie, where you have seen a very small tiny piece of um, robot or electronic circuit has been building up by itself. That is what you call the self-replicating robots. So he published a book called Engines of Creation, The Coming Era of Nanotechnology, 1986. So according to Wikipedia, it states that popularization of conceptual framework for nanotechnology began with 1986 publication of the book Engines of Creation. So which means the popularization of nanotechnology happened with the book on engines of creation, and hence he is considered as the godfather of nanotechnology. So nanotechnology, you can rephrase it as a principle of manipulation of atom by atom through control of structures of matters at the molecular level. Now, though the popularization happened very recently, the idea or nanotechnology was practiced in 4th century itself among the Roman glassmakers. Hope you have observed the windows and the glass paintings on the windows of Roman cathedrals, where you can see different colors, very different colors have been intricately joined together to form very beautiful picture. Here itself you can see. So do you think it was glass painted by the Roman glassmakers? No. What they did was they impregnated different sizes of silver or gold into the glass, and depending upon the size of the silver or gold, it appeared differently. And another example is Lycurgus cup, which is a soda lime glass, which is again impregnated with silver and gold nanoparticle. And what is the specialty of that? It is the same glass which is observed under reflected light, and this is observed under transmitted light. So under reflection or transmission, it appears as differently. So under transmission, what do you mean by that? If you keep a candle inside, what you get will be a transmitted light, and the cup will appear in a different color. So the application of nanotechnology was already been there, but unknowingly they have done it unknowingly. So now let's see how big this nanometer is. If you consider our palm at very small region, like 10 centimeter, so our palm length would be 10 centimeter. Now let us consider a 1 centimeter size square on your palm. So that is what is enlarged here. So then you can see like wrinkles on your grandmother's hand or your grandfather's hand. This is the enlarged view of 1 centimeter size of your palm. Now let us also enlarge again a 1 millimeter size of the palm. So then you can see the wrinkles have formed into ridges, and if you again enlarge the very small portion, you can see it has come up as valleys with great ridges, deep ridges and all. So that is the 100 micron size of the skin. Now again, if you go to the 10 micron size, where you can see red blood cells, white blood cells and all, and if you enlarge the very small 1 micron size of the, for example, white blood cell, you can see many number of in the 100 nanometer size DNA would be visible, and in the 10 nanometer size or in the 1 nanometer size you can see the atoms which constitute the DNA. So that's the scale we are speaking about, the size of DNA and atom which are in the size of nanometer range. So if you check the scale of things, what we can see is in the macro scale, and human beings, or you can see up to the level of ants, or you can see up to the level of chalk powders, so which are in the macro scale. Now if you again enlarge your view, you will come into the micro scale view, where you can observe things under microscope like bacteria, cells, red blood cells, etc. Now if you go deeper, you'll get into, that is, if you enlarge the size, then you can see, enlarge your observation, then you can see it is of the order of virus, or of the order of DNA, or of the order of water molecule, atoms, etc. So those are the scale we are talking about, that is nanometer range. So we said nanoscience as observing something, and how to identify, how to control or manipulate atom by atom. So is nanoscience is just seeing and moving really small things? Is that what we are going to do? Yes, but it is a lot more. That is, the beauty is the properties of material change at the nanoscale. What was the property of a material in the macro scale will not be there if it is in the nanometer scale. It would have been a different one, or a unique one, or a novel one. An example is, these are the solutions dispersed using a familiar material, but the material has different size. Let us see what that material is. So here you can see, depending upon the size, it is having different colors. So the optical property has changed to a great extent based on the size of